So welcome all. Today we will see something about recursive design parsers, and here basically we will start with something about the parsers. They are bottom-up parsers and top-down parsers, and then we will see that recursive design parsers are a type of top-down parser. So what happens in bottom-up parser? We build up the tree from leaves, right? We start from the leaves. We find out the handles and try to form a particular, I should say, tree. Mm. What happens here actually in this case, you will have the these things, and then you will keep on building the tree, right? So such things can be there in I should say your bottom up parser. However, in top down parser, what will happen? In top down parser, you will start with your root, and then you will try out the possible scenario for the you will choose the productions, and accordingly you will try to go to the depth first traversal and to the leaves. So what will happen, you will start from the root, and repeatedly you will pick up some productions, and according to the non-terminals of those productions you will expand those non-terminals, and then try to find out these possible options. Among these possible options, some of the options can be applicable and acceptable, right? So in recursive descent parser, as you will see, we will see that before that we are talking about top down parsing here. So basically what we have here is given a this thing derivation starting from S, you reach somewhere WXY. So what happens in between, you will pick up some production and derive them. So you will try to choose those productions which are giving you the expansion or derivation related to the string, right? So now there is something called predictive parsing. Basically, if we are not predicting anything, we are not taking care of what is the best possible thing, in that case we will be using backtracking. We will start from our root, and then we will go in a particular direction. Maybe we will choose one production and expand this production, and then we will find that okay, this thing is not acceptable, right, according to the required string. Given a string is something, suppose A, B, C, D, and here what we are getting is after expansion it is A, B, D. So since we are getting such thing, so we will backtrack from here, and then we will choose another production, and then we will see whether we are getting our desired string or not, right? However, when we are talking about predictive parsing, in that case we will try to predict path, I should say, the production which has higher probability of leading to our desired string. So what it is saying that there is one non-terminal A, and there are two productions. A derives alpha also, A derives beta also. So at a particular stage we are confused what to do, whether we should choose this production or another production. So if there is something a parsing technique where we do not need any backtracking, and we have a way to decide that choosing this production in this particular condition is better, they will be called as predictive parsers. Let be uh, we will see that these kind of parsing techniques are helpful. After this recursive descent parser, we will try to understand non-recursive descent parser, where basically we will try to understand the importance of prediction, right? So before that, understand about LLK property, okay, which grammar can be called as LL1 grammar, LLK grammar. So a grammar that has LL1 property, it means that all the non-terminals hmm, A derives alpha and A derives beta, both appears in the grammar. These are two production. In that case, this alpha and beta, if we try to find out first of alpha and first of beta, there is nothing common between them, right? This is an important thing. And if it has grammar has LL1 property, we can build a predictive parser for it that uses one symbol look ahead. Okay, so this is a property using which you can say that a grammar is LL1 grammar, right? So now you will see something about some more things. So what happens in LLK grammar? Actually, the first L you have already seen. Actually, it starts from left to right. Another L is for leftmost derivation, and another this K means that look aheads. I mean, given your string, A, B, C, D, whatever string is given. So at a particular position where you are, you can see one symbol look ahead, you know. So if you can see this symbol, that will be helpful. So one symbol look ahead is enough for many practical programming languages, and greater than one is rare actually, but for theory part we have to understand that yes, it is possible, right? So the for these kind of tables can be made to represent something that what will happen if this symbol comes. It is showing we have numbered the productions, and in tabular structure we usually show that if this symbol appears and we are with S, so which production we are going to use. Okay, in this way we can make some table. If we compare this LL with LR, in that case we can say that LR is a little what happens is okay, little better, but maybe I have written next slide. So here what I am saying is table driven parsers for both LL and LR can be automatically generated by tools. Yeah, LL1 has to make a decision based on a single non-terminal and the next input symbol. LR1 can base the decision on the entire left context, means the content of the stack, as well as the next input symbol. So LR is more powerful, or automatic tools are also there. So here we are coming for recursive descent parser. So basically what is happening is, we already know that top-down parsing technique is there. We start from root and go to the leaf. So here this is a technique which is very easy to implement, and the idea is that for each non-terminal in the grammar we will write procedures, functions. Okay, and the main function will be for the starting symbol, है ना? So from the starting symbol other functions will be called accordingly. So each of these function is responsible for matching its non-terminal with the next part of the input. Suppose this is a grammar where it is saying this is a non-terminal statement, which can be either a assignment statement, it can be a return expression, if expression statement, while expression statement. So in such case, if you want to write this method, what you will do is you will keep on writing functions for these. For a statement you have already written a function. Okay, so for what this function will do, it will check out the token, what the next token is. If it is ID, it will go for this statement. If at all it is a return statement, so it will call a return statement and break. And if at all it is if, then it will call if statement. If it is while, it will call while statement. And if it is ID, this ID, then it will call assignment statement. Very simple. So accordingly you will have to define this return statement as well, maybe all the functions, while statement, return statement and others. Okay, so in this way you will have to write a recursive descent parser. That is very simple thing, right? Now there is something you have to consider, that the parser functions need to agree on where they are in the input. When a parser function is called, the current token is the token that begins the expanded non-terminal being passed. So when a parser function is done, it must have completely consumed input correspond to that non-terminal. Okay, that is the thing. So suppose, what can be the problem related to this recursive descent parser? So actually it is a recursive function. So in some cases when such kind of expressions are there where the non-terminal is deriving the same non-terminal and something else, in that case you can understand there will be a function for this which will call itself. It is in the next slide. So what will happen in this case, the expression plus term. So what is happening for this expression method? First of all it is calling the expression function itself, and then after that the next thing, get the token and the term function, right? The token is plus. So what will happen in this case, for a simple string also, you will call this function expression, and with this expression it will first of all call the expression, right? Now this expression will again call the whole function here, and it will again call the first function expression without going to the next token, right? So what will happen? There is a bug. The problem is the infinite loop going on. There will be an infinite recursion in this thing. So that is why we have seen in the last video about the problems related to this left recursion, and how this left recursion can be removed. So that is the thing that we have seen today in this video. In the next video we will try to understand about non-recursive descent parser. Okay, so thank you.